Here we have a velocity versus time graph that we want to draw acceleration versus time graph from. And so I drew them in a way that we can work on it. So the first region I numbered as 1 is from 0 to 10 seconds. Second region is from 10 second to 15 second. And the third region is all the way from 15 second to 25 second, because this is a single line that you can find. It's supposed to be completely straight, of course. That's the best I could do. So this is a one single line that you can calculate slope of. So as we spoke about distance versus time graph, for velocity versus time graph, if you calculate slope on the velocity versus time graph, you get acceleration, okay? You get acceleration, therefore, by looking at the slopes on the velocity versus time graph, you can calculate slopes and then draw your graph for acceleration versus time for that motion. So region 1 has this really straight line, therefore we all know that the slope is going to come out to be 0, but in any case, it's an exercise. Let me make the coordinate of this point, which is corresponding to 10, 15, right? And we started with this point where time was 0. We had 15 meter per second. So basically it tells you that the object at the time that you started recording your data was moving with 15 meter per second. Therefore, time 0 corresponds to 15 meter per second. So these two data points is going to be used to calculate the slope of the first region. So y2 is 15 minus y1 is 15 divided by x2 is 10 and x1 is 0. Therefore, number 0 divided by number 0 for the slope 1. So in the first 10 seconds, your acceleration is basically 0. I could draw basically, so you don't have any acceleration. There's no change in velocity. It's a constant velocity from 0 to 10 seconds. The object is moving with 15 meters per second. So region 2, the slope for region 2 is going to be calculated between these 2 points, and so the last point is going to be on the axis 15 and y value is 20. So y2 for the region 2 is 20 minus y1, which is 15, divided by x2 is 15 minus x1 is 10. So you have 5 divided by 5, so you get 1 meter per second square. So from 10 seconds to 15 seconds, if you put 1 here, 2, 3, minus 1, minus 2, then from 10 to 15 seconds, you're going to have basically 1. And for third region, from 15 to 25, you calculate your slope by using this as the first data point and this as the last, which is then going to be x is 25, y corresponds to minus 15. So let me just write it here. So y2 for the third region is minus 15 minus y2 minus, right? Y1 is 20 divided by x2 is 25, x1 is 15. So you get minus 35 divided by 10. Therefore, you get minus 3.5 meter per second square. So your third region have the acceleration of minus 3.5. And it's minus because you know the slope is having this angle. It's pretty steep, so it's much bigger than this one, as you can see. And that's region 2 has a positive slope anyway. So from 15 to 25, we need to put a dot for, let me make it minus 3 and then minus 4. This is going to be 3.5, which is around here. So I'm going to be putting a line right here, 15 to 25, your acceleration is going to be something like that. So this is the acceleration versus time graph that you can draw by looking at velocity versus time graph, okay? So in the previous video, I showed you how to draw actually velocity versus time graph by looking at distance versus time in the case that your velocity was changing. But in that case, we couldn't do calculations, so I couldn't give you numbers for the velocity values. Therefore, I drew this graph just to discuss that how you can actually do the same thing that you did for the distance versus time graph to calculate slopes, and from the slopes, you can draw acceleration versus time. So I hope this helps for the acceleration versus time graph drawn by looking at the velocity versus time graph. And at this level, we don't discuss anything that has any motion that has a changing acceleration. So our problems are always going to be constant acceleration. Constant means for a given interval of time, you have a constant acceleration, whether it's 0, 1, a negative number, but it's always going to be constant. It's not going to have any slope by itself. Thank you.